The Milenkovich hypothesis is periodic effects of Earth's orbit around the Sun affect Earth's climate, namely Earth's cyclic stages of glaciation. The three effects hypothesized are Earth's changing, number one, eccentric orbit, which varies from circular to mildly eccentric over a period of 413,000 years. Number two, axis tilt nodding, which varies by a few degrees over a period of 41,000 years. And number three, axial retrograde precession, which repeats over a period of 25,771.5 years. The net three combined, Milenkovich hypothesized that those three could explain the gross periodic effects in Earth's stages of glaciation. It's a hypothesis by Milenkovich. The periodic effects Milenkovich hypothesized that affected Earth's stages of glaciation and the repeating effect that we see in the observations is Earth's eccentric orbit. Milenkovich hypothesized that Earth has a circular orbit going around the Sun, but sometimes it could have a really long eccentric orbit around the Sun. And the amount of time it would take Earth to have a circular orbit to an eccentric orbit back to a circular orbit was a period of 413,000 years. And that period, that changing effect in the eccentric orbit, affected Earth's stages of glaciation and the repeating stages of glaciation. The number two periodic effect that Milenkovich hypothesized that affected Earth's long-term climate was Earth's axis of tilt nodding. Currently, Earth is pointing towards Polaris. But Milenkovich hypothesized that the rotation axis wouldn't always point towards the same star, but it would nod slightly forward and then it would go nodding slightly back. So it had this periodic nodding, and the amount of time it would take to nod fully from one direction to the other direction, which is a few degrees, it occurred on a period of 41,000 years. The third periodic effect of Earth's orbit around the Sun that could affect Earth's long-term climate, Milenkovich hypothesized, is number three, the axial retrograde precession. Currently, Earth is pointing towards Polaris, but not always will Earth's rotation axis point to Polaris. It points to Vega sometimes, and sometimes it points to Thurbin. The amount of time the rotation axis takes to trace out a cone in the sky is a period of 25,771.5 years. The three periodic effects that Milenkovich hypothesized is enough to explain the global changes in the stages of glaciation and the repeating effect. Now, he hypothesized these three to occur, hence the Milenkovich hypothesis.